This video was produced by
My name is Ed Clark. I am president of the Wildlife Center of Virginia, which is located down in Waynesboro, Virginia. For those of you that have never heard of the Wildlife Center of Virginia, shame on you, but we are the nation's leading teaching and research hospital for wildlife. And we are a facility that trains veterinary students from every vet school in the U.S. and Canada and from about 42 other countries. And one may ask, hopefully with all of the proper sighting and all of the great guidelines that are going to go into place, there will be no injured wildlife associated with wind energy. I think we all know better than that, but perhaps the role that the Wildlife Center has played over the last 30 years, for which we were invited to this meeting, is one of our priorities is the monitoring of wildlife health and environmental threats that affect wildlife. And certainly development of all sorts have tremendous impacts potentially on varieties of animals, either groups of animals, be they birds, mammals, other types of vertebrates or invertebrates. But we also have a very specific spatial, temporal, and sometimes species-specific impacts of certain things. And I think one of us will be talking about the impact that wildlife health may, in reverse, have on wind energy. So we're going to spend some time this afternoon looking at that. Now, in our arena at the Wildlife Center, we have been very much bombarded with inquiries from all over the United States about the permit application that's been filed with the U.S. Fish and Wildlife Service to basically allow bald and golden eagles to be killed by wind generation. And what started off being a 5-year permit application that was predicated on compliance with guidelines established by the federal government has recently been amended. Now the applicants are requesting a 30-year permit and are requesting that that be predicated strictly on voluntary compliance with guidelines that are established. And needless to say, that has sort of escalated the interest level in that permit application by wildlife conservationists. And there are a number of national and regional wildlife advocacy groups that are engaging in that and may well, frankly, end up in court over that permit application. That's just one of many points of controversy. That happens to be in our backyard here in Virginia, but also something that's happening nationwide, and particularly in the western states. As the bald eagle population recovers, the golden eagle population is beginning to tank. And there is now a zero-take allowed in U.S. Fish and Wildlife Service regulatory regime because the golden eagle population in the United States is shrinking significantly. So we are reminded of the adage, be careful what you wish for. When we are spend decades wishing for a non-polluting, non-fossil fuel energy source, we often find that anything that seems too good to be true sometimes is. My colleagues here on the panel this afternoon are going to address various aspects of this issue and bring, I think, to you some very interesting points of view that might not readily leap to mind when someone considers wind energy development or the siting requirements or the implications for green energy for other green things. Our first speaker this afternoon is Gwen Lockhart from the Virginia Aquarium and Marine Science Center. She's a GIS research specialist at the museum and has her bachelor's degree in biology and business management from Old Dominion, post-baccalaureate certification in geographic information systems from Penn State, currently in a master's program in natural resources at Virginia Tech. She's been working with this issue on and off for 5 years. And I think has a very interesting perspective to share with us. Rick Reynolds from the Department of Game and Inland Fisheries, a wildlife biologist, will also be presenting on the panel. Our third speaker this afternoon was unable to join us at the last minute, but that will give us more time for questions and answers and discussion at the end. So with no further ado, let me pass the microphone to Gwen, and we'll turn it over to you.
Hi, thank you all for coming. My name is Gwen, and I'm a GIS specialist at the Virginia Aquarium Foundation. Today, I'm going to talk about some of the marine protected species that are present in the outer continental shelf where the proposed wind energy areas are set to be in Virginia. I'm also going to talk about some known risks and threats to marine mammals and sea turtles in these waters, and some potential risks that could result from wind energy area development. I'll also be talking about several of our research projects that we're doing at the aquarium that have spatial data implications. Okay, I gotta make sure everything's working. So the mission of the Virginia Aquarium Foundation is to promote the conservation of marine animal species through stranding response, research, rehabilitation, there's supposed to be more pictures. Isn't that advancing? Uh-oh, I think I broke the clicker. Okay, thank you. That's rehabilitation. That's one of our rehabilitated sea turtles that we released with a satellite transmitter and education. So the Virginia Aquarium Foundation responds to live and dead stranded marine mammals and sea turtles throughout the entire state of Virginia. In addition, we engage in cooperative research projects that promote conservation of marine protected species in mid-Atlantic waters. Examples of marine species of concern in Virginia are cetaceans, which include dolphins, whales, and porpoises, pinnipeds or seals. And in Virginia, we see harp, harbor, hooded, and gray seals. We also have sea turtles, including loggerheads, Kemp's ridleys, leatherbacks, green sea turtles, and we have an occasional hawksbill sea turtle come into Virginia waters. All marine mammal species in the U.S. waters are protected under the authority of the Marine Mammal Protection Act. Furthermore, the following species in Virginia are listed under the Endangered Species Act. They include the North Atlantic right whale, humpback whale, the fin whale, the loggerhead sea turtle, Kemp's ridley, and leatherback sea turtles. Overall, there's more than 30 marine mammal and sea turtle species present in the outer continental shelf of Virginia. It is important to consider that regional abundance within the outer continental shelf is dynamic and changes within and between years. The critically endangered North Atlantic right whale is an example of particular concern. There are estimated to be just over 400 right whales alive today, and the population continues to suffer unsustainable mortality rates from ship strikes and entanglement in fishing gear. The right whale migrates from its calving grounds off the coast of Florida to its feeding grounds in the Gulf of Maine, and this migratory corridor passes through Virginia waters, and any offshore development has the potential to impact this species. And you can see the star right there. That's where, roughly about where the wind energy areas would be located. Thank you. So there are several known threats to marine mammals and sea turtles. Commercial and recreational fishing interactions, including entanglement in gear, ingestion of gear and hooks, and competition between the fishing industry and wildlife for prey species. There's some pictures, I think. And those are pictures of animals that we've actually responded to at the center, and those are all entanglements. And another category of known threats includes vessel interactions. There are propeller strikes and blunt trauma, and there's also acoustic masking from ship noise, and there's more pretty pictures of stranded. The top picture is an example of blunt trauma. That would be from a vessel hull, and the bottom picture is an example of a propeller strike. So I categorized the potential threats that wind energy development in the outer continental shelf could bring to marine mammals and sea turtles as direct versus indirect. Direct threats result in are a direct result of wind energy development, and they include vessel interactions, collision and entanglement with the structures, displacement, avoidance, or injury due to the noise and vibrations from constructions or operations. And myself and my co-authors are under the agreement that this would be relatively minimal. Indirect threats are more of a concern to us because they're difficult to measure, they're difficult to predict, and therefore hard to mitigate. These threats could include effects on prey species and increased risk of fishery and vessel interaction because of the displacement of anthropogenic activities out of the wind energy areas. So why are we so concerned with displacement? The waters off Virginia are very crowded with competing human activities now, and these include commercial shipping, commercial fishing, including nets, pots, dredge and trawl, and purse seines, recreational fishing. On any given day, there could be hundreds of boats anchored and trawling in that outer continental shelf. And there's several major military installments in the Hampton Roads area, and so this area has heavy military training exercises that are numbered up to hundreds per year. And also there are frequent naval deployments. Wind energy area development will decrease the area that anthropogenic activities can occur in. The effect of this displacement on protected resources is unknown. It is important that we collect regional interannual data on species presence and habitat utilization in order to predict, detect, and mitigate these risks.
Gwen.
Okay. Oh, did. Okay, thank you. Lots of technical difficulties. So different types of spatial data can inform us about species location. Spatially relevant biological monitoring data should be included in planning and permitting stage of the wind area development. Species abundance estimates that report the number of individuals with population on a regional and seasonal basis are very important, and these can be acquired through aerial surveys. Satellite telemetry and boat-based surveys, and to some extent aerial surveys, give us an idea about how species utilize the habitat. And it's also very important to collect anthropogenic activity spatial data, such as commercial and recreational fishing, military exercise. The VDGIF collects spatially relevant data as part of our strategy response and research efforts. During our ship characterization study, we used AIS to track commercial vessels and radar to track military and commercial shipping vessels. We did this for 5 days per month for an entire year, and now this data is being used to, thank you so much. This data is being used to conduct large whale ship strike risk assessment and policy advising. We have also, in the past year, been conducting large whale photo ID and biopsy surveys, and this gives us information about species presence and habitat utilization. We are in the second year of a 3-year marine animal aerial survey study that's actually funded by the Section 6 grant, which is written into the Endangered Species Act. And we'll be using this data to calculate abundance estimates for sea turtles in the Chesapeake Bay and off the coast of Virginia and Maryland. And then, due to financial and logistical challenges of conducting effective biological monitoring of species abundance in the marine environment, These abundance estimates aren't always available for us. So in this case, the location of stranded animals can be used to report the presence of the species. In addition, necropsy or animal autopsy of stranded animals can determine the cause of mortality and be used to report mortality rates. So my next slide is a map and a histogram showing live and dead Virginia marine animal strandings from the 5-year period between 2007 and 2011. The first map shows bottlenose dolphin strandings. We had a total of 340 over that 5-year period with a yearly 5-year average of 68 and a maximum of 82 in 2009. Okay. This shows the location of large whale strandings. We had 14 large whale strandings with an average of 2 per year and a maximum of 4 in 2011. This is our location of our smaller cetaceans other than bottlenose dolphins. We had 146 over 5 years and an annual average of 24 with a maximum of 33. And this is the really big number slide. We had 1,265 sea turtle strandings during that time with an average of 211 sea turtles per year with a maximum of 253. And I should mention in the slides that the boxes out there are the wind energy area development, the lease blocks that they're proposing to develop into. We conducted large whale photo ID surveys last winter. We partook in 10 dedicated surveys from December 2011 to March 2012. In addition, we had trained volunteers collect photo ID data on local whale cruises. And my colleague, Jackie Bort, who's sitting right back there, analyzed hundreds of photographs from these cruises. And she was looking for unique patterns on the whale's flukes and dorsal fins. They're like fingerprints. So Jackie was able to identify 52 individual humpback whales that utilized the area here and 5 fin whales. So the map above shows the tracks from the 10 VDGIF cruises with it, and the points show the location of the group sightings. This map shows the results from our aerial surveys. We've contracted the Riverhead Foundation in Long Island, New York to fly surveys for us, and they will be flying from July to September in 2011, 2012, and 2013. The map below shows the preliminary results from our first year of sightings. In 2011, Riverhead flew over 14,000 kilometers of transits and sighted over 1,500 sea turtles, including 20 Kemp's Ridleys, 71 unknown sea turtles, 84 leatherbacks, and over 1,200 loggerheads. And again, you can see the wind energy areas in that last slide. Oh, and I should mention that the reason why the sightings stop offshore and we don't get the whole wind energy area is because our grant is for Virginia state waters, so we're flying inshore. In addition to sea turtles, the observers also noted the sightings of bottlenose dolphins. They saw over 2,000 groups of dolphins and over 4,000 individual animals. In 2011, NIMS, Northeast Fishery Science Center, and the Coonmanset Farm Foundation, as well as my organization, deployed a total of 51 satellite tags on loggerhead sea turtles in the mid-Atlantic. The Northeast Fishery Science Center and Coonmanset Farm captured wild turtles offshore and deployed a total of 42 tags, and my organization deployed 7 tags on rehabilitated turtles. And you can see that there is an offshore bias in the map. That's because Northeast Fishery Science Center deployed so many more tags than we do. Our rehabilitated sea turtles seem to utilize the inshore environment. The rings around the wind energy areas are each 5 nautical miles long, and so they make a 30 nautical mile buffer around the zones. We filtered the telemetry points for a maximum of 1 point per day for each animal, and we calculated that 62% of the points were located 30 nautical miles from one or more of the Mid-Atlantic WEAs. The map below was created using data from our ship characterization study. Each line represents one vessel transit. The green represents all the vessels acquired using a radar, mostly commercial fishers and military, and the purple are vessels transmitting AIS, which are mostly commercial vessels. And you can see the wind energy area, I think you have to click once more, is approximately right there, and you can see that it's heavily used by ship traffic. And I should note that the reason why our radar is so small compared to our AIS data is because our radar was considerably, the range was considerably more limited, so we weren't able to collect data in the WEAs on military and commercial shipping, or commercial fishing, excuse me. This slide shows the calculated density of all the AIS vessels tracked during this study. And the warm colors indicate a higher density. And you can again see the WEA area. And you can imagine that development of this area would displace this traffic into areas around and potentially increase the risk of ship strikes to large whales. This is a slide that kind of shows some of the indiscrepancies that may be reported when you rely too heavily on spatial data. The top map shows a screen print of humpback whale sightings taken from BOE's 2012 Commercial Wind Lease Environmental Assessment. This map was created using sighting data reported in the Nature Conservancy's 2011 Eco-Regional Marine Assessment, and the grids represent all whales sighted between 1979 to 2011. And the bottom map shows the map that I presented before, showing our photo ID and biopsy studies, and the red rectangle. The red rectangle frames the area in the environmental assessment map that we surveyed. And you can see that there are the number of whales in the top map are underreported if you consider our surveys this year. And there's several possible reasons for an underestimation like that. First, they might lack a consistent interannual regional surveys, and this could have caused a misrepresentation of long-term ecological trends in whale populations' behavior. In addition, the study did not use or factor into perception or availability bias into their distance model that they used to calculate their grid. And basically, a perception bias has to do with an observer's inability to see an animal due to factors such as differences in water turbidity and changes in sea state. An availability bias has to do with a researcher's inability to see the animals that are under the water surface. So there's different ways to deal with this. One of them is using satellite telemetry data to calculate a ratio of time that the average sea turtle would spend underwater and put that into a statistical model. So my co-authors and I came up with some suggested priorities. We would like the agency to continue support for regional interannual marine aerial surveys such as AMAPs. We'd also recommend the development of methods to reduce bias associated with marine animal abundance estimates. Current sighting data used in most NEPA analysis in the Mid-Atlantic does not account for perception and availability bias in any of their density calculations, and this results in underestimation of some species abundances in the study areas. The acquisition of spatial data for anthropogenic activities such as fishing and military activity should be a priority. We do have a really interesting data set from AIS, but that only represents commercial vessels. We'd also advocate for the development of interorganizational cooperation and data sharing protocols to facilitate the availability of data to agencies prior to action implementation. And this slide just kind of summarizes all the spatial data that we've been collecting. That's our sea turtle aerial survey data. You can click on it again. That's our bottlenose dolphin sightings. And over off of Virginia Beach is our large whale photo ID and biopsy surveys. That's our sea turtle telemetry data points. That's the AIS tracks for all the shipping. And that's the wind energy areas. So there's a lot to think about with that slide. So that's it. Thank you for your attention.
Great. Well, thanks, Gwen. And we will have plenty of time for questions at the end. Our next speaker is from the Department of Game and Inland Fisheries, my old friend Rick Reynolds. Well, I'm old and he's my friend. How about that?
Yeah, I'm catching up with you here. Just real quick here, because what you're going to see is that my presentation is not what's, I guess, in the pamphlets there that you have. When they were calling for papers, I actually submitted 2 papers or 2 presentations, and they told me to select the one that I wanted to, and I did, and they selected the other one. So, so basically what I'm going to talk to you today about are the impacts of white nose syndrome on bat populations in the eastern United States and some considerations with wind energy development in light of white nose syndrome. Okay, all right, we're gonna go with manual. All right, so to start out with, we're just gonna do a little bit of bat biology to go over a couple of issues that are pertinent both to white nose syndrome and wind energy. And when we look at bats in the eastern United States, we can basically stick them in 2 categories depending on where they hibernate. So if the bats spend their winters in caves or mines or structures like that, we came up with this great term calling them cave bats. And so there's a list of some of the cave bats, not all of them. If a bat ends up spending the winter in trees, we end up calling them tree bats. There are really kind of 3 true tree bats, the red hoary silver-haired. They are either in Virginia or they travel through Virginia during the migratory season. Something to keep in mind with this is that cave bats right now are the group of bats that are really being impacted by white nose syndrome, and we've not picked up white nose syndrome in tree bats. Tree bats are the group of bats that seem to be more heavily impacted by wind energy, even though cave bats do show up at facilities. Okay. Probably a couple of the traits to also keep in mind with bats in general is their whole approach to, I guess, productivity and longevity, promoting populations and species. They are opposite of most small mammals. Most small mammals, they have high productivity. They have multiple litters per year. They have lots of individuals in a litter per year, but they have a short lifespan, say 1 to 4 years. Bats, on the other hand, typically it's 1 or 2 individuals, 1 or 2 young, only 1 litter per year, and they are long-lived. So they will live 12 plus years in the wild. All of our bats in the east are insect eaters. And so basically you end up with 2 strategies to deal with that because you have no food in the winter time. So you can either build up enough fat reserves going into hibernation, or you can travel a longer distance and go down to milder climates where there is food in the wintertime. And we kind of have a combination of the both here in Virginia, and some species kind of are a combination of the two as well. Okay. All right, so around 2006, 2007 in that wintertime, white nose syndrome shows up in New York. It's a fungus that grows on the bats. It grows basically on exposed skin, so around the muzzle, and this kind of shows you where the name white nose came from. But it also grows on the wing membranes, the tail membranes. The fungus actually grows into the dermis or into the skin of the bats. And so basically two kind of issues come out of that. Number one, you can obviously see how it's an irritant, especially when you see it growing around the muzzle like that. If you were to ever open up and look at their wings, they can be heavily infected as well. So what we find with bats that have the fungus on them in the wintertime are these increased arousal bouts. Bats normally wake up through the winter time during the hibernation period. You can't hang on a ceiling for 4 or 6 months, so you got to get up and stretch on occasion. But what we find with the fungus is that they are arousing more often and they're staying awake for a longer period of time. And basically what that does is it depletes those fat reserves that they build up when they go into hibernation. And what that does is it may compromise them with respect to even making it through the hibernation period. And then something that we don't have a good handle on at this point in time is what are those impacts when they leave in the springtime. So they survive the winter, but they leave in poor condition. And where that's probably more critical is with the females that have to go out and have young and raise young. The other thing that they're looking into with this is because it is getting into the dermis, is affecting the hydration of the bat, and thus they think are probably causing other imbalances with respect, to other fluid systems in the bats. Okay. All right, so I'm going to kind of walk you through what's happened with white nose syndrome from its first onset in 06-07. In the legend, you can see the year there at the top, and you can just kind of follow that. Here's where it originally started at 4 or 5 Ks around Albany, New York. Within 1 year, it's spread further in New York and then to the states to the east. The following year, it now runs pretty rampant. It's going down the Appalachians. It's in Pennsylvania, West Virginia, and Virginia. Go ahead. And we had another year to it, and now it's moving south and west through Tennessee, Missouri, and Oklahoma. And now it's jumping into Canada and moving north and west through Canada as well. You jump another year, and basically we're just kind of filling in the dots, if you will. We're adding additional counties. All right, hold on this one. No, go back. All right, that's good. We'll see. Go forward one more. All right, we'll hang out right here for a second. This is the most recent map as of last week. And so where you're seeing now where we're just kind of adding more counties and provinces up in Canada, but you're also seeing it spreading into some other states. As of last week, we can now add Iowa to this map as well. Now, one of the things that people discussed when white nose first showed up and it started to move, and especially looking at it moving south, was whether or not fatality rates would change as white nose progressed to the south. The idea was that the hibernacula periods as you go south, well, the climate's milder, so the hibernation periods are shorter. You also have more breaks in the wintertime, so the thought was that there were greater opportunities for bats to get out in the wintertime, perhaps build up fat reserves, and hopefully somewhat fend off the white nose fungus. Let's see. But what we ended up finding was that didn't seem to be the case. So here are just a subset of hibernacula in the mid-Atlantic region. These are little brown bats, and you'll see that we have a 90+% fatality rates at these sites, which is right on par for course with what they've seen up in the northeast. Go ahead. The tricolored bat is another cave bat, and outside of a couple of anomalies there that can be explained by year of infection or else by the site itself, we have 90+% fatality rates with that species. This is the Indiana bat, and in the Northeast, the fatality rates are more in about the 70% range. What we're seeing here is just kind of a mix of things. Pennsylvania looks like they got hit pretty hard with 90+%. West Virginia, not quite as hard, and in Virginia, we're kind of all over the map. We think that this is probably more of an issue of white nose, the year of infection, if you will, and that probably within another year or two, will probably be looking like they are in the Northeast. Okay. All right, so for some of our cave bats, we don't have the best hibernacula data. This is the northern long-eared bat, and this shows you mistnet captures in the summertime. It's fairly noisy data, but it's a big data set coming out of Pennsylvania, and I think the bottom line here is you just see that declining trend there with that species. Okay. Perhaps a positive note is the big brown bat. I know this kind of shows you a little bit of a decline in the population here, but because that data is so noisy, that line is probably doesn't have any statistical value to it. And with other data and anecdotal information that we have, we actually think that the big brown is probably holding its own with respect to white nose. Okay. So what does all of this mean, and how does it really apply to wind energy? Well, what has happened with these high fatality rates is that the Fish and Wildlife Service is being petitioned to list species under the Endangered Species Act. Right now, there are 3 species that they're looking at. The small-footed myotis and the northern long-eared myotis are both formally petitioned for listing. The little brown bat I have up there as a kind of, because it was being petitioned for emergency listing. Fish and Wildlife Service talked to the group that was asking for the listing, asked them to hold off on a formal petition, and that they would look at the little brown in conjunction with the northern long-eared and the small-footed. So you've got those 3 species that they're looking at this point in time. Fish and Wildlife Service is going to turn around and look at all the cave bats just because of the impacts of white nose on them. And I'm just showing you some of the other species and perhaps the order that they will look at them in. Okay. If you remember early on, I mentioned that the fatality rates at wind facilities was pretty much more dominated by the tree bats. And this pie chart shows and supports that for a number of facilities in Pennsylvania. So you have about 70% of your fatalities being made up of tree bats, the hoary, silver, and red. But also, if you look in there, about 25% of the bats are cave bats. And I think the important issue here, and something that is somewhat being teased out by this data, is that it depends on the location. Some of the, this is just overall for like 8 facilities, I believe. But if you start looking at individual facilities, you'll see that sometimes the cave bats are a smaller percentage, and in other times they're in a larger percentage. And we'll come back to that issue in a minute. Okay. So what that brings us to are some management considerations with respect to wind energy. And this is nothing new. Location, deterrence, and curtailment are 3 ideas that wind energy has been looking at and dealing with kind of since the onset of bat issues. But I think that they need a little closer or different look at now that we have white nose showing up in the picture. Okay. So, much like real estate, location, location, location. This shows you major hibernacula in Virginia. And as I mentioned before, some of the facilities where they've had the higher fatality rates with cave bats are where they have been positioned closer to hibernacula. So in looking at basically site placement, this is a good tool to look at. Basically, you don't want to be putting a wind turbine site right on top of a major hibernacula, because most likely you're going to be looking at some issues there. And part of that has to do with behavior. What these cave bats do in the fall is they basically migrate back to these hibernacula. they swarm around the hibernacula, and they move between hibernacula. So you kind of want to avoid and stay away from those areas. All right. This, I think, is probably the tool that a lot of us would like to see come to fruition, and would maybe be the saving grace, both for bats and for wind, if you will. But is acoustic deterrence. Basically what you see here on, I guess on the left side of the screen there, is a prototype for the acoustic deterrence. Basically what they do is you put these on the turbines, they emit high frequency sounds. Those high frequency sounds basically jam or confuse the bats and basically shove them away or keep them from coming into the turbine itself. Okay. So they have looked at this deterrent device more in kind of a lab setting and then also in a controlled field setting. What I'm showing you here is an actual application of the device on turbines. So Arnett and his folks up in Pennsylvania placed deterrents on several turbines and ran those for a couple months to see what kind of results that they ended up with. And they kind of got mixed results out of it. They had anywhere from 18 to 62% reduction in fatality rates. And I think because of that large variance and some other issues in there, they felt that it was kind of inconclusive as to exactly how effective these things were. And I think mostly they felt that they needed some additional studying of this. But a couple of things that they brought out with it is, number one, is the attenuation of these high frequency sounds. So when they send them out, the distance that you can basically send a high frequency sound is fairly limited. They attenuate over a short distance. The higher the frequency, the shorter the distance it will travel. And that's where the effectiveness by species comes into play. Tree bats, for the most part, are a lower frequency emitting bat. The cave bat's a higher frequency. So you will probably get better results or better deterrence, with the tree bats than you will with the cave bats. But they felt that it looked fairly promising. They think that there are some modifications that need to be done to this whole system, and then of course some additional studies to look at that. All right. Our best tool at this point in time is curtailment. And there are a couple good studies out there, Bearwald up in Canada and Arnett again in Pennsylvania. And they looked at changing the cut-in speeds of turbines and those impacts on bat fatality rates. In Canada, they set their cut-in speed at 5.5 meters per second. They ran it for 1 month, and they got an overall 60% reduction in fatality rates. They then looked at the revenue that was lost from applying that 5.5 meters per second at those 15 turbines for 1 month. And it cost in the neighborhood of $3,000 to $4,000. Now, you need to take that with a grain of salt because there are a lot of issues out there that affect the cost. Now, number one, the cost of energy is going to change over time. Number two, it depends on how many turbines you're running out there. They only applied it to the 15 that they put the turbines on, but that facility probably had at least twice as many turbines out there. And also, it's going to depend on how long you run it. So they only ran it for 1 month. Now, Arnett, they took kind of a little different approach to it, and they wanted to look at two different cut-in speeds. So they looked at 5 meters and 6.5 meters, and they ran it for a couple months. They got a little wider range in their results, but overall, they had pretty good results of 82 and 72% reduction. But that also kind of shows you that annual variation that you might see in doing this as well. And again, they did kind of a cost estimate, if you will, that looked more at the power loss. And they applied it to all the turbines. They used 5 meters instead of 6.5 meters because they didn't find a real big difference in fatality rates between using 5 meters and 6.5 meters as their cut-in speed. And so they saw a power loss of about 1% by applying the 5 meters per second to all the turbines for basically a 2-month period. Okay. So the bottom line is with our management considerations, we still have these 3 ideas out there. And looking at location, avoiding putting facilities in close to major hibernacula will be a plus, at least with respect to the cave bats. The curtailment, right now that's our best management alternative for reducing bat fatalities, and it's across the board, whether they are cave or tree bats. And lastly, deterrence, kind of the golden key, if you will, if we can make that thing work. And that's all.
Okay, well, we're all going to move back over here to the table. I'm not sure what protocol was established here for submitting questions, but we're a fairly intimate group here, so I suspect I see some on cards, and if you didn't get your cards and letters in, it's not too late. You can write it on the back of a $20 bill and pass it down to the front. We'll be sure to answer those first. One of the frustrating things working in the policy end of things is with the wonderful research that's going on is trying to get regulators to require the permitted community to collect data that is meaningful and standardized across not just a given industry, such as the wind energy, but between permitted activities. The U.S. Fish and Wildlife Service, as an example, probably has 20 different permit programs, and yet no two of those programs uses the same report. No two of those reports uses the same standardized data set. So a bald eagle could be called 4 different things in those reporting systems if there were even an attempt to compile them, which there's not. It would be meaningless because there would be no way whatsoever to look at cumulative impacts. As we begin to see the limitations of just pure field research, it's hard to count things that move. And if you're out doing a tree survey, they're going to be there tomorrow if it rains you out today. Moving animals, that's quite another thing. But one of the issues that those of us who are advocates for strong policy will be bringing to this debate is the admonition that accurate, standardized, and truly comprehensive reporting needs to be an aspect of siting and permitting, not only for wind energy, but we're actually going back and recommending modifications to existing regulations for other regulated activity. We may well find that industries such as the wind energy development are relative drops in the bucket compared to other types of anthropogenic causes of wildlife mortality and morbidity, but we just don't know at this point. And so we have to be operating within the system with which we're dealing, which is activity by activity, site by site, smokestack by smokestack. So let's see what some questions might be. Gwen, are you ready?
I think so.
Okay. Have there been any studies done on the possible impacts of offshore turbines on sea turtles or dolphins? If yes, what are these impacts? Oh, sorry.
I think that most of the research having to do with the impact of offshore turbines has had to do with the noise of the turbines, and I don't really know any specific studies that do cite that. Jackie, she's back there. She's an acoustic expert that I work with. Do you know any specific studies that have to do with the wind turbines and acoustics?
There's stuff out there, but it is mostly about the acoustic impact, and a lot of it is more the construction of the wind turbines and the turbine development needs. But I would say that the impact is fairly minimal compared to things like shipping and stuff like that.
Yeah, there's really not any studies about sea turtles. It mostly focuses on marine mammals because the acoustics do affect marine mammals more because they echolocate.
Okay. Hopefully that addressed the question. If anyone submitting these questions wishes to follow up or clarify or say, hey, you didn't answer my question, feel free to leap to your feet. Rick, this one is for you. Would high-frequency deterrent equipment have an effect on any other species other than bats? And have any studies been done to show secondary impacts or secondary effects of high-frequency deterrents?
Yes, I don't think that there have been other studies per se, but there is the idea that these high-frequency deterrents potentially affect insect activity, which is potentially, kind of more of a plus, because there is the idea or the thought that insects may be drawn into turbines, whether it's because of the heat or what have you, and therefore, if these deterrents are going to basically deter the insects and deter the bats, then it's kind of a win-win situation in that respect.
Okay, surprisingly enough, there's one for me. And I didn't put it in here. I mentioned about the concern about eagles and the permits. There was recently an article in the Richmond Times-Dispatch. A spokesman for the American Bird Conservancy was very critical of the wind energy. And the question is, what's the best way to deal with bald eagle concerns in Virginia? Boy, I wish I had the answer to that. I would send an assistant to this meeting. The truth is that part of what we're missing is data. We don't actually know enough about migratory patterns, and part of it is that money for pure research, either in academic institutions or our management agencies, has been very, very limited. It's hard to get people to pony up money to study things that aren't at the time threatened or endangered just for the sake of pure knowledge. The bald eagle, of course, we poured millions and millions of dollars into bringing that flagship species back from the brink of extinction. In 1970, there were probably 25 to 30 nesting pairs in the entire state of Virginia. This year, 2012, we believe that the total number of nesting pairs is probably in the neighborhood of 1,000, give or take 200. So that's a meteoric increase, and that population is continuing to expand by about 10% per year. But in the western part of the state, one of the issues we've got is the golden eagle. We have a very limited, very small, very locally specific seasonal population of golden eagles, and they migrate right down the ridges, as far as we know, that are being proposed for location of wind generation facilities. Part of the issue is being able to get to the table with adequate data on the impacts of wildlife in a timely manner. When some of these data are not available and a permit process is rolling ahead, and with all of the pressure that exists in Virginia specifically, but nationwide, to make the permitting process fast for the industry, it's very difficult to bring to bear all of the information that needs to be filtered in a permitting system. So I think it goes back to a number of things from my point of view, and it basically comes back to the data issue. If you are going to predicate a permit, predicate development on limited knowledge, there needs to be built in a system that allows expanded knowledge to affect the continued development or the continued activity of either that industry, that location, or that operation strategy. Right now, that's not a part of the permitting process. The federal permit that is now under fire, and the 30-year period of that permit certainly is understandable from the investment point of view of those that are building generating facilities, but from the point of view that we have very limited data, those data are being expanded every year, that 5 years from now we may find out that something critical was overlooked if we are then having to just sit and wait another 25 years to introduce those new data to the process. That's just not an acceptable procedure for many of us who are advocates in this field.
Yeah. I'll add a little bit more to that. My counterpart, Jeff Cooper, this has to do more with golden eagles and not bald eagles, but they have been putting satellite transmitters on golden eagles out in the western part of the state, basically from Highland County, gosh, I think at least all the way down to Tazewell County. And so these are baited sites where basically they throw deer carcasses out, and they are coming up with more golden eagles than they thought were out there in the first place. And just looking at the transmitter data of these eagles moving around, they end up here in the state basically every month out of the year. So something that we didn't know. So there was a lot of good information that's coming, out of this work. It's pretty new. They've only been doing it for a couple of years, and they're working with folks in Pennsylvania that are doing the same thing, and I think West Virginia. So we'll end up with some pretty decent data with golden eagles.
Okay, next question we have, we'll assume is for Gwen. Are there data showing actual effects of wind energy areas in established offshore wind sites in other parts of the world?
The only studies that I've heard of actually say that the wind energy areas in Europe attract marine mammals and create a refuge area, which is really interesting. However, the Mid-Atlantic is a completely different ecosystem than Europe, and so a bit along the lines of what they were saying about collecting data, we really want to collect this baseline data on species abundance so we know what's out there now. So if we go and we develop the wind energy areas and continue to collect data on a fine scale, then we'll be able to say that the areas are affecting or creating more of a risk or not creating a risk, and it would help the developers and the policymakers and the scientists in the long run.
I like to hear myself talk, I guess. But I would just add something else. This is more with respect to bats, but there have been studies with offshore facilities and bat fatalities, and this is mostly over in Europe where they have some offshore facilities there, and they have picked up bats coming out to these sites. I guess there are a couple theories or ideas behind it. One being that they are these very large structures that are sticking up on the landscape. Most of the bats are out there during migration period. They look and they see these things and perhaps think that they are very large roost and head to those sites. The other one that I had mentioned before is that you do have insect activity around them. So it is one of the questions that's out there is if you move turbines offshore, are you going to have fatalities with bats offshore? And so that's one study at least out there.
Yeah, and it's unfortunate that among our panelists we don't have an avian specialist looking at this. There's a huge amount of energy and interest in the avian effects. Some of us are constantly reminded of the old Saturday Night Live skit about the Bassomatic where you would put the fish in the blender, but it's not quite that simple. The truth is, though, that the rule of unintended consequences is often at play when we move in new directions. And these are among the types of issues that, honestly, we're just beginning to peel this onion and try to determine what information we need in order to make appropriate decisions, appropriate siting decisions, so that we can develop new sources of energy, sustainable sources of energy, without at the same time throwing out the baby with the bathwater. And it's very ironic that the environmental community has pushed for non-carbon fuel energy production, and now we find that factions of that same community are pitted against one another over what is the priority and how do we prioritize and what information do we need. It's just not that simple in dealing with dynamic living systems. Does anybody else have any questions? We do have a little bit, well, maybe a time for one or two more questions. Yes, please. Identify yourself, please. And
I have a question for Gwen, if I may. Have you seen any studies about the effects of the magnetic fields of the AC and DC power lines on wildlife?
I have not. Have you, Jackie? Sorry.
I've heard to date, I've read a few studies in Europe, and to date there is no proof that these EMFs, these fields, actually harm marine life. I'm not saying that they're not, but most likely they don't think it does. They don't think that it's strong enough to actually harm marine life.
Again, tough to prove a negative, but I've been following this from a wildlife health point of view, and I certainly have seen nothing to indicate that that should be the top problem on our list of concerns. Of course.
For Rick, if I may, with the whole help of Gwen, I know that on fishing nets, they put pingers on them to try to discouraged the dolphins from coming into the nets, and found out that they actually attracted them in some cases. Are these high-frequency things that you're putting on the blades, is there any possibility that those will actually attract the bats instead of the children?
I don't believe so, and they're not putting them on the blade, they're putting them on the nasal, and so, which is the very top part of the pole that the blade attaches to. Because I don't think that technically you can stick them on the blades. I think those things are probably so precisely made that to put a foreign object like that on them probably wouldn't work. But they first tested these kind of more in a lab setting. They actually went out to a pond where they had a lot of bat activity over it, and they set the deterrent more on the ground, broadcasted it over part of the pond, and it basically pushed the bats away from that part. They stayed in the other half of the pond feeding and drinking over there, but would not come over to the area where they had the deterrent.
Yeah, so these are not the wind energy equivalent of deer whistles that they sell you for the front bumper of your car, which also don't work.
With respect to data that would be, I think, useful, I think it's a very good point. And, I know, for instance, in Virginia, there is some eagle nest data that Brian Watts has put together at the Center for Conservation Biology, right? And additionally, they have, some data they've gathered through telemetry, tracking where some of the bald eagles go. And so, it's a case of observation. I don't know if, Rick or Ed, you might want to comment, but some of those telemetry, data sets as they come in probably could be useful to the developers in the earliest stages of site selection, much like, Rick, as you put the map up that shows hibernacular locations. Because the way the draft eagle guidelines are set up by Fish and Wildlife Service at stage 1, as early as possible, if you can look at published data sets, it can move the developer away from an area that's not useful. So, I think as you said, Ed, data sets are needed, especially with gold eagles and such. But I guess the point I want to make is that earlier that some of the published data sets can be available and shared with developers, then they can actually use them in the earliest stages of their site selection.
Yeah, and of course, one of the problems that we encounter in gathering and sharing data, particularly that originating in academic institutions, is till it's published, they're not sharing it with anybody. And that's unfortunate. But in any case, I want to thank my colleagues for their presentations. I want to thank you for your kind and gracious attention, for the fine questions. If any of you would like to visit with us after we're done here, please come down and see us. Otherwise, thank you for being here, and we are adjourned.